Recording in progress.
So we were discussing yesterday about the changing of the states and the crystal lattice and the pattern. Can you tell me the brief overview? What
I'm
is
not sure.
lattice? Hmm? About the
I'm not
lattice.
sure.
Okay. So in solids, when we talk about the solids, there is a regular arrangement. Okay. What is the arrangement of the particles in the solid?
Tight,
Hmm.
closely
Yeah,
packed.
they are closely packed. There is tight packing. It's like a crystal clear structure. So whenever we talk about the solids, we say that they are arranged in a regular pattern, and this regular pattern is known as lattice. Okay, this is known as
Mhm.
lattice, and there are strong forces in them. But in liquids, there are some of the there is loose packing as compared to the solid, and there are weak forces. Okay, in liquid there are weak forces as compared to the solid. And when we talk about the gases, they have almost no forces holding them together. Okay, there are almost the
Mhm.
intermolecular forces are negligible in them. Okay, you can neglect them, the intermolecular interaction in the gases. Are you clear with this? The difference of the particle arrangement of the solid, liquid, and gases. This we have done a detailed discussion on this in the first lecture, if you remember. If you want, we can revise. Otherwise, we can move forward.
Yeah, I know it's fine.
Okay. Then we discussed about the changing states. Okay, when we talk about the changing state, I was giving you the example of the solid, how from the solid a liquid is formed. First thing is that keep in mind what is the arrangement of solid, that the particles are closely placed to each other. Okay, there is a tight packing, the particles are closely placed and their vibrations are on the same position. Okay, they are moving to and fro or above and up and down in the within their same fixed position. But when you
Mhm.
heat a solid, what will happen? You are heating, so it means you are providing energy. Okay, you are providing energy to the solid, and this energy will what will it do? It will break the intermolecular interaction. Okay, intermolecular interaction in solids. Okay, basically, if you remember in solids, we have discussed that in solid there is tight packing. There are strong intermolecular forces, right? Those strong intermolecular forces are holding these atoms,
Mhm.
right? So when you will
Yeah.
heat, what will happen? This heat energy will break this bonding. Okay, this heat energy will break this bonding. It will break the intermolecular interactions in the solid. And once there is breakage in the bonding, what will happen? There will be slightly more vibration. Initially in
Mhm.
solids, we say there are very less vibrations. Okay, there are less vibrations in the solid. But when
Mhm.
you heat it, what will happen? The bond will break, and in result of this bond breakage, the vibrations will increase. Okay, the vibrations will increase, and when the vibration will increase, what will happen? There will be more movement. Okay, more random movement. The particles will
Mhm.
their random movement will increase. Okay, and you are keep giving them heat, so that heat will be used up to break the intermolecular forces, to make those intermolecular forces weak. Okay, and when
Mhm.
the melting point will reach, that solid will melt into a liquid. Clear?
Yeah.
And this liquid is expanded. Okay, if you see solid, this solid has a compact structure. Okay, this solid is having a compact structure, right? But when you heat
Mhm.
it, it will be expanded, right? You see,
Mhm.
it is expanded now. The atoms are away from each other. There are more observable intermolecular difference. The difference of the intermolecular forces is observed in this. Okay, they are distant apart from each other.
Mhm.
Clear? Now, can
Yeah.
you tell me how melting is done and what is the chemistry behind this? How how you can melt a solid?
Uh, y- to melt a solid, you like the vibration. You have to heat. You have to heat You have to heat it, and then the vibration will get larger, and then it will melt.
Yes, basically, you will say that you are heating the solid, and then how that solid is being converted into liquid, you will tell that heat energy is used to break the intermolecular interactions. Okay, the
Yeah.
heat which you are providing to the solid, that heat energy is used to break the intermolecular interaction in the solid. Are you clear?
Yes.
What will happen next when the intermolecular interactions will become weak? What will happen?
It will
The
it will
vibrations will,
explode, get larger.
yes, vibrations will increase, and the atoms will be, there will be distance in these atoms, okay? The particles will be distant apart from each other. There will be observable distance between these particles, among all these particles. And at the melting point, the solid will melt into a liquid, okay? And when the solid is melted into a liquid, this is known as, that liquid is expanded now, okay? The liquid is expanded now. Are you getting this?
Yes.
Okay. And that is why liquid take more space as compared to the solid, because the atoms, because the particles in the liquid are having some distance in between them. But when we talk about the solids, in the solids there is close packing. They are very close to each other. Clear? That's why the solid have a compact structure.
Yes.
Okay. Then there is, sorry, I,
Nothing.
okay. Okay, when we talk about the boiling, now you can tell me what will happen if you have a liquid, and how, what will happen in this? Just a random idea, then I will tell you, inshallah.
Like, how does liquid become solid?
No, boiling. What is boiling? The liquid will boil, and what happens when a liquid boils? Okay. Have you seen any liquid being boiling? Just like the water, the boiling of water. What happens?
Yeah. It like it
Hmm.
has it
Some
causes
particles,
bubbles to form.
yeah, bubbles form, and those bubbles evaporate, right? Those
Mm.
bubbles
Yeah.
evaporate in the air. So that is boiling. How boiling is occurring? Basically, you have this liquid, and you are heating it. So what is happening when you are providing the heat energy to this liquid? This heat energy will be used to break the intermolecular interactions. Okay,
Hmm.
because we have discussed that when you are heating the liquid, you cannot say that all the intermolecular forces are ended up now. It is not the case. Now there will be
Hmm.
less intermolecular forces. In the liquid, there are less intermolecular interaction as compared to the solid. Okay, less intermolecular interaction,
Force.
hmm, interaction or force as compared to the solid. In the, we are
Yeah.
talking about the liquid. Okay, so it has some of the intermolecular interaction in it. Clear? So
Yes.
what will happen when you heat the liquid? Those, that heat energy will be used up to break those intermolecular interactions. Okay, to basically increase the vibration in the liquid. Okay, and how the vibration will increase? There will be more breakage of intermolecular interaction. Okay, we are
Hmm.
discussing that in liquid there are intermolecular forces as well, but those intermolecular forces are weak as compared to the solid. Okay, but they
Hmm.
are present. So when you provide heat to this liquid, that heat energy will be used up by the liquid to break those intermolecular interactions. Clear?
Yeah.
And once these intermolecular interactions are broken down, what will happen? The vibration will increase. Okay, the
Mm.
vibration will increase, and then this liquid will convert into the gas. Let me write it over here. What I'm saying. I'm particularly talking the about the melting and boiling. Firstly, when we talk about the melting, in melting, we say that there is a solid, okay? That solid will be converted into liquid. Okay, this is known as
Mhm.
melting of solid. How it will happen? Firstly, you are providing heat energy, okay? You have given heat
Yeah.
energy, that heat energy to the solid.
Mhm.
What will happen? This heat energy will break the intermolecular interactions, okay? It will break the intermolecular forces because
Mhm.
we have discussed that what is the strength of intermolecular forces in solid? Are they strong or are they weak in solid? Intermolecular
Uh,
forces.
strong.
Yeah, they are strong. So this heat energy is used to break the intermolecular forces. What will happen next? When there will be breakage of intermolecular forces, the vibrations will increase. Okay, vibrations in solid will increase, and ultimately at melting point, at melting point, what will happen? This solid will be converted into liquid. Okay, and that liquid
Mhm.
will be expanded. Okay, the solid was compact and the liquid will be expanded. Are you clear? I have written MP.
Yeah.
MP is the melting point. I can write over here.
Mhm. Yeah.
Now, can you tell me how the solid melts into liquid?
This like it breaks down into intermolecular forces, and then like the vibration in solid will increase, and then it will expand, and then liquid is formed.
Yes. Basically, when that heat energy is being used up to increase the vibrations, okay? That heat energy is
Mhm.
used to increase the vibration. Similar is the case for from liquid to gas. Like you have boiling. In boiling, what we discuss, there is liquid, and then this liquid will be converted into gas. Okay, when you are providing it
Mhm.
heat. This triangular sign is for heat, and you are providing it specific heat. You will you will see this in chemistry book in the reactions. Whenever there is a sign arrowhead and a triangle like this, this triangle represents the heat that you are giving the heat. Okay.
Mhm.
So in boiling, what will happen? You know, in the liquid there are vibrations, there are intermolecular forces, right? So you have this liquid and you have provided it heat. Okay, you have provided it heat energy.
Yeah.
What will happen next? This heat energy will be used up by the liquid. Okay, and this heat energy will break the intermolecular forces. I'm writing IMF, okay, intermolecular forces present in liquid, okay.
Mhm. Yeah.
Then what will happen when the intermolecular forces will break? What will happen next?
Then it will
Then vibrations will increase, right?
increase.
Because ultimately you are heating. If you just imagine that you have particles and you are giving heat, okay, you are giving heat. So what will happen? Their intermolecular forces. Now you have these particles have used this heat to break the interaction. And when
Yeah.
once the interaction is being broken down, what will happen? The vibrations will increase. It is just as you are holding your friend's hand, okay? So you are controlling him. You are not letting him go, okay? But once you free him from your hand, what will happen? He can go in the random position. He can go anywhere, okay?
Mhm.
He was specifically following some conditions when you were holding his hand. Similar is the case
Yeah.
when there were intermolecular forces, they were on the same position. Okay, But when you given the heat to these particles, what happened? The interaction was now become weak. The interaction will become weak because you are providing heat. That heat energy will break the interaction. Okay.
mhm.
And once the interaction is weak, what will happen? The vibrations will increase. You see, now the vibrations will increase and the particles will move fast. And at the boiling point, the some of the particles will evaporate, will leave the surface. Clear? Are you clear with this process, or should I repeat this?
No, I got it.
Okay. Can you tell me what is happening?
In liquid to solid or solid to liquid?
Uh, Not liquid to solid. That is liquid to gas. This is liquid to gas. This is not
Oh,
liquid to
yeah,
solid.
yeah, liquid to gas.
Liquid
Yeah.
to gas. I'm talking about liquid to gas.
It's where they use heat energy to liquid, and then the intermolecular forces like it like expands, and
Hmm.
I can I
There's
forgot the
so, but
like after it expands.
like when you are providing the heat energy to the liquid, the this heat energy will break the intermolecular forces present in the liquid, right? When the intermolecular
Yeah,
forces will break, what will happen? The vibrations will increase. Okay,
yeah,
vibrations will
yeah, vibrations.
yeah, vibrations will increase. Now the particles will move fast.
Yes, and
Particles,
that
yes,
net space.
hmm, motion will increase. Then what will happen?
It will expand.
Hmm. Yeah, there will be bubble formation, the gas
Yeah.
formation, and this gas formation will happen at boiling point. Okay, at boiling point.
Hmm.
At boiling point, this will happen. You will get the gas molecule. There will be gas formation. Clear?
Yes.
And some of the gas particles will evaporate. They will escape the surface, and we will discuss how evaporation will occur. And this is the scenario over here. Okay. Now evaporation. What is evaporation? It is when you are heating these, you are providing heat. What will happen? At boiling point, the liquid is converted into gas, right? And you will observe whenever the water is boiling, some of the bubbles they leave the surface. Okay, they leave the surface.
Yeah.
They evaporate. Why they evaporate? Because they get extra energy. They have extra energy. They have enough energy to leave that system. So they leave the liquid part. They leave the boiling water part. Okay, they convert into the gaseous form and they enter into the air. Okay, so this is known as evaporation. That they have mentioned even well below the boiling point, some particles in liquid have enough energy. Some particles in the liquid have enough energy to escape and form gas. This is known as evaporation. Are you getting this?
Hmm. Yeah.
That some particles they get extra energy in this. How they will get extra energy? Maybe they will absorb more energy. Okay, they will absorb more energy and they will escape the system. They will leave the system. This is known as evaporation. And always remember this will happen at the surface. Okay, this is not happening inside. You will always observe evaporation at the surface. It will happening at the surface. So that is why we say evaporation is a surface phenomenon.
Hmm.
Okay, I am repeating this. I am saying that when the particles will gain energy, there will be some particles which will gain enough energy to leave the system. They will have some extra energy that will help them to leave the system. Okay, and they will
Hmm.
leave from the surface. Okay, it's not the case that evaporation is happening throughout. It is not the case. Evaporation is not happening throughout. It is just happening with the particles which are present on the surface. Okay, they will leave the surface. So that is why we
Hmm.
say evaporation is a surface phenomenon. Are you clear?
Yes.
It is slow as compared to the boiling. It is slow process as compared to the boiling. Why it is slow? Because you see the when we talk about the boiling, boiling is happening throughout the liquid. Okay, boiling is happening
Yeah.
throughout the liquid, but the evaporation will happening only it is happening on the surface. So firstly, why evaporation is slow? Because as we have seen that the particles will evaporate from the surface. So it means firstly particles need to reach the surface. Okay, firstly particles need to reach the surface. So they will take time. That's why we say evaporation is a slow process. Again, I am repeating
Mm-hmm.
that for evaporation, what we say the condition for evaporation is that it will happen on the surface. Okay, and for as this is a surface phenomena, so firstly particles need to reach the surface. Okay, so for reaching to the surface, they need some time. That's why we say evaporation is a slow process. Clear? But
Mm-hmm.
when we talk about the boiling, boiling is happening throughout the liquid over here, over here, over here. It does not need to reach the surface. So that's why boiling is a fast process as compared to the evaporation. Okay, write the
Mm-hmm.
question. This is your homework. You will send me. What is the difference between evaporation and boiling? Two differences, two key differences.
Okay.
I will give you some more questions as well. Just write. This is the first question. You have notebook right now?
Not right now. I'm just gonna write it on a Word file.
Okay. What are the two key differences in the evaporation and boiling?
Between boiling and evaporating.
Yes.
Okay.
The next question is how heat energy will help to convert liquid? How heat energy
Yeah. Yeah.
how heat energy will help to convert liquid into gas?
Okay. Okay.
Okay. So this was the evaporation. The evaporation takes place at the surface of the liquid and over a range of temperature. It happens over a range of temperature at different temperatures. But for boiling, there is a fixed temperature. Okay, boiling will happen at a fixed temperature, just like we talk about water. You know the boiling point of water?
100.
Yeah, 100 degrees Celsius. It will boil at 100 degrees Celsius. Okay, it cannot
Yeah.
boil at 99. It cannot boil at 98. Okay, degrees Celsius. It will just boil at 100 degrees Celsius. So this is a fixed
Mm-hmm.
point, fixed value. For boiling, boiling take place at a fixed temperature, at a specific temperature. But evaporation can happen at any temperature. Okay, like even
Mm-hmm.
if at 60 degree, you are boiling water at 60 degree, you are heating water at 60 degree. So it will not boil, but some particles may evaporate. Some particles may escape. So why they can escape? Because evaporation does not need a specific temperature. Evaporation can happen at any temperature. Clear? But for boiling
Mm-hmm. Yeah.
and for melting, you need specific temperature. Melting happen at specific temperature as well as boiling happen at specific temperature. Okay? Are you clear with
Yeah.
this?
Mm-hmm.
You have any question?
No.
Okay. Then there is how much heat is needed. Okay, now firstly tell me what is the difference between evaporation and boiling over here.
Uh,
Any
d- d- like the difference between boiling,
and
like
evaporation.
yeah, the temperature is different at
Hmm?
like the temperature is different to boil. You need like 100 degrees and
For boiling, you need a specific temperature, but for evaporation,
yeah,
you don't need specific
you
temperature
need
for evaporation. Okay, evaporation can
yeah.
happen at 60 degree or 70 degrees. I'm giving you the example of water. Like water will boil
Mm-hmm.
at 100 degrees Celsius, right? But
Yeah.
evaporation in water can occur at like it may occur at 60 degree, it may occur at 70 degree, 80 degree, at any temperature. Okay, so this is one difference. Yeah, and evaporation is what? It is a surface phenomena. What is meant by evaporation is a surface phenomena?
Like it happens on the surface, like above
Hmm.
gas.
Okay,
Even yeah.
above the liquid surface. Okay, it will
Yeah,
happen
like
above the
yeah.
liquid surface. But
Yeah.
the boiling is continuous. It is continuously happening inside the liquid. Okay.
Yeah.
So these are some of the differences. And one more thing, why we say evaporation is a slow process?
Because because the particles are
Mhm.
like slower
Firstly, keep in mind,
in
firstly
boiling
remind this to yourself. What is evaporation? Firstly, remind this yourself. Where evaporation happens?
when something is boiling.
On surface. Okay. Evaporation happens at
Yeah, on
the surface of the liquid. Okay. Now, I am asking why evaporation take time? Because,
because it's on the
hmm, hmm,
it's like on the surface. It takes time to
yes,
reach.
yeah, the particles will take time to reach the surface. That's why evaporation is a slow process as compared to the
Hmm.
as compared to the boiling. Okay,
Yeah,
boiling is a fast process, but evaporation, because why boiling is a fast process? Because for boiling you don't need particles to the particles don't need to be to reach the surface. Boiling can happen inside the liquid at any way inside
yeah,
the liquid. Okay, just when the 100 degree will
hmm,
reach, the particles will start to boil. The specific condition for boiling is that you
hmm,
need a specific temperature. Okay, I hope you are clear
yeah,
till this. Okay,
yeah, yeah. I got it. It takes time.
okay. Then there is how much heat is needed. Now the question arises that we are discussing that we will provide heat energy, right? We have discussed in the above as well that solid you will provide heat energy, it will convert it into liquid. Similarly, the liquid will gain heat energy and it will be converted into a gas. Now the question arises how much heat is needed. So they have mentioned the amount of heat needed to melt or boil a substance is different for every substance. Okay, this is just for example, you have
Yeah,
water in glass, and in a separate glass you have milk. Okay, now you are boiling these two. These two will
hmm,
boil at different temperatures. For water, the boiling temperature is 100 degrees
yeah,
Celsius. For milk, it is some other value. I don't remember the exact value of the milk, but I'm just giving you the idea that every substance has its specific boiling
yeah,
and melting temperature. Okay? And why is it so? Can you
hmm.
tell me what? Just think about it. Why every substance has specific value of boiling and melting temperatures?
Maybe because like it has different particles inside each substance.
Yes, exactly. Like the milk, the composition of milk is totally different from the composition of the water, right? So when the
Yeah,
composition is different, so obviously you will think when the composition is different, the ingredients in the milk, their atomic level bonding will also be different, right? There will be different bonding in the milk. The atoms will be bonded with some other kind of the bonding, and similarly in the water there is some other type of bonding. So that's why you need there is a change. There is the melting point and the boiling point of different substances will be different. You will not see that all the substances are boiling at the same temperature or all the substances are melting at the same temperature. This is not the case. Different substances have different boiling and
yeah,
melting temperatures. Okay. Why?
yeah.
Because their bonding pattern is different. Their bonding pattern is different. Now they have mentioned. Okay, one more thing. If we compare water and milk, and let's say water has more boiling point. It has high boiling point as compared to the milk. Why is it so? What can be the reason?
Uh,
Hmm.
maybe because of like it has
Because
different type
because of
of
the interaction. Think about the
temp.
interaction of the atoms.
Yeah.
They have different interactions, right? They have different type of bondings. Maybe in water there are
Yeah.
strong forces, okay, as
Yes.
compared to the milk,
Yeah.
okay.
Mm-hmm.
So that's why milk appear to boil faster,
Yeah.
okay. Because in milk there are fats and there are proteins.
Yes.
They can rapidly rise, the fats and the proteins in the milk. That's why
Yeah.
the milk has lesser boiling point as compared to the milk water. Okay,
Mm-hmm.
are you clear with this? How much heat is needed? If I ask you how much heat is needed, what will be
Not
your answer?
fully.
Sorry,
How much? How much was needed?
heat is needed in any type of chemical reaction. How much heat is needed? So how will you justify this? Like I am saying, there are two solids, and those solids are needed to convert into liquid. So, how much heat is needed for those two solids? Those two are different solids. Okay. Now, my question is that
Yeah.
how much heat is needed for them to convert into liquid?
It, it's different for each substance. So, like, it
Why
depends
it
on
will be
the
different?
forces
Hmm.
because the difference attract like the forces and attraction of each substance.
Firstly, you must know that uh, substances in every substance particles are different. Okay. Just like in the water, you have just
Mm-hmm.
hydrogen and oxygen, right? In water, you just have
Yeah.
hydrogen and oxygen. But in milk, in milk there is 85 to 87% water, and rest of the substances are fat and protein. Okay, these are the things in the milk. So there
Yeah.
are different particles
Mm-hmm.
in the milk as compared to the water. So that is why there will be
Mm-hmm.
different forces of attraction in milk, and there will be different forces of interaction in the water. So there is a difference in their
Yeah.
forces of attraction. So that's why you need
Mm-hmm.
different amount of heat for these two substances. And in which substance you need more heat? Obviously, in that substance you need more heat in which there are strong forces. Okay,
Okay.
just like if we talk about the milk and water, we say that water is
Mm-hmm.
having more boiling point. Why? Because the water is having more
Yeah.
stronger interaction as compared to the milk. Okay, are you getting this?
Mm-hmm.
There are two
Yeah.
different things which we are discussing in this heading. Firstly, we are discussing that the about the atoms, about the intermolecular forces, that in different substances there are different atoms and there are different intermolecular interactions, right? And second thing which we are
Yeah.
discussing is that when there are different atoms, so obviously their interaction will be different, and their forces of attraction will be different. When forces of attraction are different, you need to provide them different energies, okay, for boiling or for
Mm-hmm.
melting. Clear? Now, can you tell me how much heat is needed if you want to convert two solids into two different liquids?
Uh, it will be needed on like it will be needed on the different like the different particles and how strong the forces are and the attraction between both substance.
Yes, it depends on it. Okay. Then,
Yeah.
if you want to reverse the change, okay, what you need to do? Firstly, let's discuss about the kinetic particular theory. According to this theory, this is a theory which was given for the particles, how particles move, how they interact, and what is the bonding pattern. Okay, it simply tells you about that. The first thing is that a substance can be solid, okay, or liquid or gas and change from one state to another. Do you agree with this statement? that a
Mm-hmm.
substance can be solid, it can be liquid, it can be gas, and it can change its state.
Mm-hmm.
Do you agree with this? Yes or no?
Mm-hmm. No. Mm-hmm.
No. Why? Can't they change their state?
Yeah.
Like you have solid, if you melt, what will happen?
Gases, but gases can't go back to state.
They can go back. They can, you can compress the gas and you can compress it into liquid.
Oh, okay.
You can go backward as well. So this is
Oh, okay.
correct. Okay. And then there is, it has
Mm-hmm.
different characteristic in each state. Okay. Every substance, they're saying solid, liquid, and gas, they have different characteristic in each state. For example, we say solid do not flow, right? This is correct. Solid do not flow. If you
Yeah.
want something to flow, you need to convert that thing into liquid. Just like you have sugar, because you have sugar crystals like this.
Mm-hmm.
But these sugar crystals, they cannot flow. What you need to do? You will dissolve this in water, right? And then you can allow that water to
Mm-hmm.
flow. Okay. So you
Yeah.
cannot directly allow, you will not see any case in which solid is flowing. Solid do not flow. So this is what they have
Mm-hmm.
mentioned. This is the second point of this kinetic particular theory. Then there is, the differences are due to the way its particles are arranged. Okay, how solid, liquid, and gases are different. This we have discussed in the first lecture. They are different on the basis of their particular arrangement. How the particles are arranged.
Yeah.
How they are arranged in solid and liquid and gas.
In solids, they're arranged like a lattice, like
Yes.
closely packed,
Hmm.
and and what's it called in liquid? They're arranged like close together, but
There are some free
but it's
spaces
like
as well, right?
yeah,
It is, you can say in
yeah,
liquid
and
it is
gas.
not that compact structure. There are some
Mhm.
of the spaces available in the liquid. There are some observable spaces available in the liquid.
Yes,
Okay. Next.
and for gas, and for gas is like randomly arranged. Like all the
Hmm.
particles are far
Hmm.
apart
Yes, they are far apart from each other. Why they are far apart?
because it has like it has like low force of attraction.
Yeah, very less intermolecular interaction in the
Yeah.
gases. Okay, that's why there is arbitrary motion. They randomly move anywhere in any direction. The gases can randomly
Mm-hmm.
move and they have random motion. Okay. So all these ideas they collectively known as kinetic particular theory. They can ask you, this is tested. Okay, this is important. What are the postulates of the kinetic particular theory? Okay. What are the postulates? I'm writing over here.
Mm-hmm.
This is also the question. Write the question. Question number 3. What are the postulates of the kinetic particular kinetic particle theory? In this, you will mention all these three postulates. Okay. Are you done with the question? You have read, right? Have you written the question?